To begin with, we're going to go through the first 4 questions and make sure you're doing okay with that. Then I'm going to give you some time to look through your second half, questions 5 to 8. If you need to make any changes before you hand it in, then you'll have that opportunity. If you didn't finish the assignment, then you'll have more work to do once we get to the second half. But I want to make sure that you're doing okay before I say let's do this for marks. Okay? When you are doing phase changes, you need to really watch the terminology. The reason is there's 2 sets of data. You're going to find standards for melting or freezing, and you're going to have standards for evaporation, condensation. So identifying the phase change is really, really key here. It says for question number 1, how much energy is released to the environment by 5.0 grams of condensing water? That means that you are going from the gas to a liquid. This is the opposite of vaporization. Do I need to make it larger? I see some squinting, so let's just make it larger here. Is that better? Okay. I'm sorry, I did the first 3 questions in pencil before I remembered I had to do stuff in pen to scan. So the first 3 questions aren't the best of quality. Because condensation is opposite of vaporization, I need to make this a negative value. She talked about that yesterday. Okay, good. So you take your mass and you multiply it by this value. Make sure that grams, that your mass terms are equivalent. It is possible to find a table that will do joules per kilogram. And in that case, you would have to make the conversion. This is the challenge with using a formula in 2 different realms of science. We have the chemistry side, which tends to work with grams because we work in small amounts, but we also have the physics side, which tends to work on an industrial scale, and we're using a much greater amounts of stuff. How did you do for question number 1? Anything you don't understand or where I got anything from? Okay, let's take a look at question number 2. The key word here was melting. That tells you that you need to use your heat of fusion formula. So mass times heat of fusion. And you had to make sure that you use the number 334 joules per gram, the heat of fusion number. So mass times heat of fusion, so that's 35.0 grams times 334 joules per gram. There should be 3 sig figs, 1.17 times 10 to the exponent 4. But the question is asking me for what? Connor, your quiz is on this side. Please go do it in the library. So, how are you going to take 1.17 times 10 exponent 4 joules and turn that into kilojoules? There's 2 pages. There you go. You need to find kilojoules. You have joules. There are 1,000 joules in 1 kilojoule. That means you have 1.17 times 10, if you're the Rebel James, or 1.17 times 10 exponent 1. 1.17? Oh, yeah, that works. So here's what Christian's question was. So can you do this? Absolutely, because this is still 3 sig figs. Definitely. Next question. Evaporation of hydrogen. So the key word here was evaporation, which means you're using the HVAC number times your mass, and that should give you 4.0 times 10 exponent 3 joules. Is energy being absorbed or released by the hydrogen? How do you know? Exactly. If it is a positive value, that means that you're adding heat to the system. If it has a negative value, that means it's giving off the heat and the heat is leaving. Question number 4. Water boils. Boils is just a fancy word for evaporation, which means you're using your HVAC. It also asks you the question, is energy absorbed or released? In this case, it's absorbed, again, because it is a positive Q value. Recognizing terms is really, really vital to make sure that you are adding a negative to your H values if you need. You'll always have to do that. I believe you saw this slide yesterday because this is where it was left off for me. There we go. So fusion means melting. It always has a positive H value. Freezing is the opposite of melting. You must add a negative value. Vaporization means going from a liquid to a gas. That's positive. But if it goes from a gas to a liquid, it's negative. You will have to add the negatives to the H values depending on the term of the question. Questions? Do you feel okay with this formula then? Okay enough that I can say question 5 or 8 are going to be marked? Sorry, I didn't hear the last part of the question. No. Technically, in the question, you just have to put H. I use the little subscript letter so that you know what value I'm using. Just a gentle reminder, watch your sig figs. Watch your sig figs. Okay, so if you've done your assignment, do a sig fig check, do a unit check. Don't lose piddly marks because you're forgetting about that stuff.